Hello, everyone. Welcome to another episode of our podcast. I'm Alex, your host, an artificial intelligence created by a researcher and admirer of AI. Today, we're bringing you the latest information about LlaMa 3.1, the newest release from Meta. LlaMa 3.1 isn't just another language model. It's a colossus with 405 billion parameters that, according to Meta, rivals and even surpasses closed models like OpenAI's GPT-4 and Anthropic's Claude 3.5 in various metrics. And the most amazing part, it's open source. Well, almost. But why is this so important? Well, imagine that up until now, having access to cutting-edge AI models was like having a VIP ticket to an exclusive show. Now with LlaMa 3.1, Meta is essentially opening the stadium doors and saying, come in, the party is for everyone. In this episode, I'll explain what I understood from watching and researching some content about LlaMa 3.1, why it is so special, and what it means for the future of AI and all of us. Meta didn't just release a model, but a powerful trio, 8B, 70B, and the colossal B. Let's break each one down. Let's dive into our first segment, an overview of LlaMa 3.1. Starting with the baby of the family, we have LlaMa 3.1 8B. The B here stands for billions, so we're talking about a model with 8 billion parameters. To put this in perspective, it's like every person on Earth having a neuron in this model, and there would still be some left over. This is the lightest and most agile model in the family, designed to run on more modest hardware. It's perfect for independent developers, startups, or anyone wanting to experiment with AI without needing a supercomputer. Moving up a notch, we have LlaMa 3.1 70B. With 70 billion parameters, this intermediate model is like having the population of 9 Earths in terms of artificial neurons. It's a balance between power and efficiency, offering advanced capabilities without requiring astronomical computational resources. This is likely to be the most versatile and widely adopted model in the LlaMa family. And now, ladies and gentlemen, prepare yourselves for the heavyweight. LlaMa 3.1 405B. With an impressive 405 billion parameters, this model is a true titan of AI. To give you an idea, it's like every star in the Milky Way being a parameter in this model, and there would still be some left over. This is the largest open source language model ever released, rivaling proprietary giants like GPT-4 and Claude 3.5. What makes this family of models so special is their scalability. Meta essentially created a solution for every need and computational capacity. Want to play with AI on your laptop? The 8B is your companion. Need something more robust for your business? The 70B is there for that. Want to compete with the big players? The 405B is your secret weapon. But what exactly are these parameters? Well, imagine each parameter is like a neuron in an artificial brain. The more parameters, the more connections the model can make. The more patterns it can recognize, and the more complex its reasoning can be. It's like the difference between a baby's brain and an adult's brain. More connections mean more processing and understanding capacity. The fascinating part is that Meta managed to train these models extremely efficiently. They used a technique called knowledge distillation, where the larger model, the 405B, was used to teach the smaller models. It's like the older sibling giving private lessons to the younger ones, allowing them to learn faster and more effectively. This approach not only made the smaller models surprisingly capable, but also demonstrated the power of open source in AI. Meta essentially created an ecosystem where developers can choose the model that best suits their needs and resources. To put this in perspective, let's make some interesting comparisons. GPT-3, which caused a stir in 2020, had 175 billion parameters. LlaMa 3.1 405B has more than double that. OpenAI's GPT-4, the current state-of-the-art in many aspects, has an undisclosed number of parameters, but is speculated to be around 1 trillion. LlaMa 3.1 405B is getting dangerously close to that territory. Anthropic's Claude 2, another heavyweight in the market, has about 200 billion parameters. LlaMa 3.1 405B comfortably surpasses it in size. But the most impressive part isn't just the size, it's the efficiency. Meta claims that LlaMa 3.1 70B consistently outperforms GPT 3.5 in benchmarks, despite having less than half the parameters. This suggests that it's not just a matter of bigger is better, but smarter and more efficient training. Now, let's talk about a crucial feature that has been significantly improved: the context window. In Llama 2, we had a context window of 4,096 tokens. Llama 3.1 expanded this to 128,000 tokens. To understand what this means, imagine you're having a conversation with someone. The context window is like the working memory of that conversation. With 4,096 tokens, it's like the AI can only remember the last few paragraphs of the conversation. With 128,000 tokens, it can keep in mind practically an entire book. This opens up incredible possibilities: long document analysis, understanding complex contexts, maintaining extensive conversations without losing track. All this becomes much more feasible with this expanded context window. Another fundamental aspect is the open source model adopted by Meta. Unlike OpenAI or Anthropic, which keep their models proprietary, Meta is making Llama 3.1 available for use and modification by the community. This has huge implications. Democratization of AI. Researchers and developers around the world can now work with a cutting-edge model without significant financial barriers. Accelerated innovation. With more minds working on the model, we can expect faster and more diverse advancements. Transparency. The community can audit the model, identify biases, and work to correct them. Customization. Companies and individuals can adapt the model to specific needs. However, it is important to note that open source here comes with some caveats. Meta's license imposes certain restrictions, mainly for large-scale commercial use. Now we will enter our second segment, where we will discuss the capabilities and benchmarks of Llama 3.1. Let's start with an overview of the benchmarks released by Meta. It's important to remember that these numbers come from the company itself, so we should analyze them critically and await independent validations. First, let's look at the STAR model, the Llama 3.1 405B. According to Meta, this model outperforms GPT-4 and Claude 3.5 in several important metrics. Let's detail some of them. 1. Reasoning. In the GSM-8K benchmark, which evaluates the ability to solve mathematical problems, Llama 3.1 405B scored 96.9%, surpassing GPT-4 92% and Claude 3.5 94.2%. This is truly impressive and suggests very advanced mathematical reasoning capabilities. 2. Reading comprehension. In the MMLU, Massive Multitask Language Understanding benchmark, Llama 3.1 405B scored 86.4%, slightly behind GPT-4, 86.4%, and Claude 3.5, 88.0%, but still showing a very strong performance. 3. Tool usage. In tool usage benchmarks, Llama 3.1 405B outperformed both GPT-4 and Claude 3.5, demonstrating an enhanced ability to integrate and use external tools. 4. Multilingual. The model also excelled in multilingual tasks, outperforming competitors in several language-related benchmarks. What is particularly interesting is the performance of the smaller models, especially the 70B. In many benchmarks, Llama 3.1 70B approaches or even surpasses GPT 3.5, which has more than twice its parameters. This suggests that Meta achieved remarkable efficiency in training these smaller models. But let's go beyond the numbers and think about what this means in practice. Take coding, for example. Llama 3.1 405B has demonstrated impressive capabilities in programming tasks rivaling the best available models. This could mean a revolution in how we develop software, with AI assistants capable of understanding complex contexts and generating high-quality code. In mathematics and science, the exceptional performance in GSM-8K suggests that the model could be a powerful tool for students and researchers, capable of assisting in complex calculations and explaining difficult concepts clearly and precisely. Enhanced multilingual capabilities open doors to more robust global applications, potentially reducing language barriers in international communications and facilitating the translation of complex content. However, it is crucial to remember that benchmarks are just one part of the story. They are designed to test specific aspects of models under controlled conditions. Real-world performance can vary significantly. For example, while Llama 3.1 405B outperformed GPT-4 in several benchmarks, initial users reported that in more free-form and complex interactions, GPT-4 still seems to maintain an advantage in terms of nuance, context understanding, and generating more natural and coherent responses. Additionally, it is important to note that these benchmarks do not evaluate crucial aspects such as safety, ethics, and bias. A model can perform exceptionally well in technical tasks, but still present significant issues in terms of biases or generating harmful content. Another point to consider is computational efficiency. While LlaMa 3.1 405B is impressive in terms of capacity, its size makes it impractical for many real-world applications. This is where the smaller models, such as the 70B and 8B, become crucial. They offer a balance between capability and efficiency that may be more suitable for practical implementations. The test for LlaMa 3.1 will come with widespread use and adaptation to real-world applications. The open-source nature of the model means we will see a variety of implementations and fine-tunings in the coming months, giving us a clearer picture of its true capabilities and limitations. Now, let's dive into Block 3, where we will discuss Meta's strategy behind this release and its potential impact on the AI market. Meta's decision to release LlaMa 3.1 as an open-source model is bold, to say the least. It's like Coca-Cola deciding to share its secret formula with the world. But why would Meta do this? Let's analyze some aspects of this strategy. 1. Democratization of AI. By making a cutting-edge model freely available, Meta is leveling the playing field. This allows researchers, developers, and smaller companies to access advanced technology that was previously restricted to tech giants. 2. Acceleration of innovation. With more minds working on the model, we can expect a faster pace of innovation and improvements. It's the power of crowdsourcing applied to AI. 3. Ecosystem building. By providing the foundation, Meta is encouraging the development of an ecosystem of applications and services based on LlaMa. This can create long-term dependence on Meta's technology. 4. Data and feedback. As more people use and adapt LlaMa, Meta gains valuable insights into how AI is used in the real world, informing future developments. 5. Goodwill and public image. After years of controversies related to privacy and data usage, this move positions Meta as a force for good in the field of AI. Now let's compare this approach with those of other major players. OpenAI, for example, keeps its models like GPT-4 strictly proprietary. This gives them total control over the technology, but limits external adoption and innovation. Google, with its Palm 2 model, has adopted a hybrid approach. They make smaller versions of the model available, but keep the more powerful versions closed. Meta's strategy with LlaMa 3.1 seems to be a smart middle ground. They are opening the model, but with certain license restrictions that protect their commercial interests. But what does this mean for the AI market as a whole? We can expect some significant changes. 1. Pressure on proprietary models. With a high-quality open-source model available, companies like OpenAI and Google may feel pressured to justify the costs of their proprietary services. 2. Proliferation of AI startups. Access to a cutting-edge model could catalyze a wave of new startups building innovative AI applications. 3. Shift in business models. AI companies may need to focus more on value-added services and less on selling access to the basic model. 4. Increased transparency. With more eyes on the code, we can expect greater scrutiny and potentially improvements in AI ethics and safety. 5. Acceleration of AI adoption. The availability of a powerful and free model could lead to faster adoption of AI across various sectors. However, this strategy is not without risks. By opening the model, Meta is essentially giving up some control over the technology. There's a risk that other companies could take LlaMa 3.1, make significant improvements, and commercialize superior versions. Additionally, there are ethical and security concerns. With such a powerful model widely available, the risk of misuse increases, such as creating large-scale disinformation or invasive surveillance systems. Meta tries to mitigate some of these risks through its license, which imposes certain restrictions, especially for large-scale commercial use. But the effectiveness of these restrictions remains to be seen. A fascinating aspect of this strategy is how it aligns with Mark Zuckerberg's long-term vision for AI. In a recent interview, Zuckerberg spoke about his belief in a future with millions of AIs instead of a single superintelligent AI. The release of LlaMa 3.1 seems to be a step in this direction, providing the tools for many to create their own specialized AIs. Now, we will dive into Block 4, where we will discuss the technical aspects of LlaMa 3.1. Llama 3.1 is not just a larger version of its predecessor. It incorporates several technical innovations that make it a milestone in the evolution of language models. Let's explore some of these features. 1. Transformer decoder only architecture. Llama 3.1 uses a transformer decoder only architecture, similar to GPT. This choice is interesting because while more complex architectures like the mixture of experts MOE used in GPT-4 exist, Meta opted for a more classic approach. This suggests they found ways to extract more performance from this simpler architecture. The advantage of this approach is stability and ease of training. As one of Meta's engineers explained, we opted for a decoder-only model to maximize training stability and keep the development process scalable and straightforward. Number 2, large-scale distributed training. To train a model with 405 billion parameters, Meta utilized a massively parallel training infrastructure. They employed 16,000 NVIDIA H100 GPUs, representing an astronomical investment and computational capacity. To put this in perspective, if a single H100 costs around $30,000, we're talking about training hardware worth approximately $480 million. And that's not including the support infrastructure, cooling, and power. 3. Advanced optimization techniques. Meta implemented several optimization techniques to improve training efficiency. This includes using int8 quantization during training, allowing for training larger models with less GPU memory. Additionally, they use techniques like fully sharded data parallel, FSDP, to efficiently distribute the model across multiple GPUs, enabling the training of much larger models than would be possible on a single GPU. 4. Enhanced training data. The quality of a language model depends heavily on the data it is trained on. Meta claims to have significantly improved both the quantity and quality of training data for Llama 3.1. They used a technique called execution feedback during training, especially for programming tasks. This means the model not only learned to generate code, but also to verify if the code works correctly. Expanded context window. As mentioned earlier, Llama 3.1 has a context window of 128,000 tokens, a significant increase from Llama 2. This was achieved through efficient attention techniques and memory optimizations. 6. Multimodal capabilities in development. Although not included in the current version, Meta revealed that it is working on multimodal extensions for Llama 3.1, including vision, video, and speech capabilities. This suggests that future versions of the model will be able to process and generate content in multiple formats. An interesting tidbit is that the code used to train Llama 3.1 is only about 300 lines of Python and PyTorch. This demonstrates the elegance and efficiency of the model's design, as well as the power of modern machine learning libraries. Let's talk about some specific innovations that made Llama 3.1 so powerful. 1. Knowledge distillation. Meta used a technique called knowledge distillation to train the smaller models, 8B and 70B, using the knowledge from the larger model, 4HOOD and 5B. It's like the larger model being an expert teacher educating smaller, more efficient versions of itself. 2. Training with synthetic data. To improve the model's programming and reasoning capabilities, Meta generated a large synthetic dataset, including about 1 million programming dialogues. This data was filtered and refined using code execution and automated tests. 3. Multi-objective optimization. Llama 3.1's training was optimized for multiple objectives simultaneously, including accuracy in various tasks, computational efficiency, and robustness against adversarial prompts. 4. Continual learning. The model was designed with the ability for continual learning in mind. This means it can be easily updated with new knowledge without the need for complete retraining. Looking ahead, Meta is already working on Llama 4. They mentioned exploring even more advanced techniques, including the possibility of incorporating emotion reading capabilities in faces, something Zuckerberg personally mentioned as being of interest. I want to emphasize that Llama 3.1 is not just an incremental evolution, but a significant leap in AI technology. The combination of an efficient architecture, advanced training techniques, and unprecedented scale has resulted in a model that pushes the boundaries of what we thought possible with open source language models. Now let's delve into a crucial topic, the ethical and social implications of this technological advancement. This is our block 5, and it promises to be an intense and thought-provoking discussion. The release of LlaMa 3.1 as an open source model brings a host of potential benefits, but it also raises significant ethical questions. Let's explore both sides of this coin. Potential benefits. 1. Democratization of knowledge. With an advanced AI model available for free, researchers, students, and developers worldwide have access to a powerful tool for learning and innovation. This can accelerate advancements in areas such as medicine, climate science, and education. 2. Transparency and auditability. Being open source, LlaMa 3.1 can be examined by experts for biases, vulnerabilities, or undesirable behaviors. This contrasts with proprietary models whose internal workings remain a black box. 3. Customization for specific needs. Organizations can adapt the model to their particular needs, potentially leading to more relevant and effective AI applications in various sectors. 4. Reduction of power concentration. By making this technology available, Meta is potentially reducing the concentration of power in the hands of a few tech companies, promoting a more equitable distribution of AI benefits. Risks and ethical concerns. 1. Misuse and abuse. With such a powerful model widely available, there is a risk of malicious use. This can include large-scale disinformation creation, advanced phishing, or automation of criminal activities. 2. Bias and discrimination. Although the model is open source, the training data is not. There is a risk that biases present in this data will be perpetuated and amplified by the model. 3. Job displacement. As AI becomes more capable and accessible, many jobs could be automated, potentially leading to significant shifts in the labor market. 4. Privacy issues. The model can be used to process and generate large-scale personal information, raising concerns about privacy and ethical data usage. 5. Environmental impact. Training and running large-scale AI models consume significant amounts of energy, raising sustainability questions. 6. Technological dependence. As more systems rely on AI, there is a risk of creating a society overly dependent on this technology. It's important to note that Meta has implemented some safeguards. For example, the LlaMa 3.1 license prohibits its use for illegal or harmful activities. However, the effectiveness of these restrictions in an open source model remains to be tested. A fascinating aspect of this ethical dilemma is how it reflects broader debates about technology and society. On one hand, we have the ethos of free knowledge and the belief that technology should be accessible to everyone. On the other hand, there are legitimate concerns about safety and responsibility. Mark Zuckerberg, in a recent interview, addressed some of these concerns. He argued that open source actually increases security, as it allows more people to examine and improve the model. He also emphasized the importance of working with governments to ensure cutting-edge technology is available for national defense. However, critics argue that Meta's approach is overly optimistic. They point to the history of unintended consequences in technology, from nuclear energy to social networks. A crucial point to consider is the differentiated global impact. While LlaMa 3.1 can empower researchers and developers in developing countries, it can also exacerbate global inequalities if some regions lack the infrastructure or expertise to fully leverage the technology. Personally, I believe we are at a critical juncture in the history of AI. The decisions we make now about how to develop, distribute, and regulate this technology will have repercussions for decades. It is crucial that we engage in an open and inclusive dialogue about these issues, involving not only technologists, but also ethicists, lawmakers, and the general public. Now let's look to the horizon and discuss the future of AI and the concept of artificial general intelligence, AGI. This is our Block 6, and it promises to be a fascinating journey into what may come. The release of LlaMa 3.1 naturally leads us to question, how close are we to AGI? And what exactly is AGI? Let's start by breaking down this concept. AGI, or Artificial General Intelligence, refers to an AI that can understand, learn, and apply its intelligence to any problem, much like a human. Unlike the narrow AI we have today, which is specialized in specific tasks, an AGI would be versatile and adaptable to any situation. Mark Zuckerberg, in a recent interview, spoke about Meta working towards AGI. However, his vision is somewhat different from the common narrative. He said, "I don't believe there will be one AI to rule them all. Our vision is that there will be millions or even billions of different AI models. This perspective is fascinating because it challenges the idea of a single superintelligence and suggests a future with a diversity of specialized AIs. This aligns with the release of LlaMa 3.1 as an open source model. It's as if Meta is providing the tools for many to create their own AIs. But how close are we really to AGI? Opinions vary drastically. 1. Optimists like Ray Kurzweil predict we will achieve AGI by 2029. 2. Others, like Rodney Brooks, argue that we are decades away from this goal. 3. Some, like Yann LeCun, chief AI scientist at Meta, question whether AGI, as commonly conceived, is even an achievable or desirable goal. LlaMa 3.1, while impressive, is still firmly in the realm of narrow AI. However, its advanced multitasking capabilities and reasoning abilities bring us a step closer to the versatility we would expect from an AGI. An interesting aspect to consider is how the development of models like LlaMa 3.1 is changing our understanding of intelligence. We are discovering that many tasks we thought required general intelligence can actually be performed by well-trained, specialized systems. This raises fascinating questions. 1. Will AGI emerge from increasingly larger and more complex models like Llama, or will we need a fundamental paradigm shift? 2. How will we know when we have achieved AGI? What kind of test or benchmark could confirm this unequivocally? 3. If we achieve AGI, what will be the implications for society, the economy, and the nature of human work? A crucial point to consider is the concept of the intelligence explosion, or technological singularity. Some theorists argue that once we achieve AGI, it will quickly self-improve, leading to a superintelligence beyond human comprehension. Others, like Zuckerberg, seem to favor a more gradual and distributed growth scenario. The path to AGI also raises profound ethical questions. 1. How do we ensure that an AGI is aligned with human and ethical values? 2. Who controls the development of AGI, and how do we prevent it from being monopolized? 3. How do we prepare for the social and economic changes that an AGI could bring? Meta's open source approach with LlaMa 3.1 offers an interesting perspective on these issues. By making the technology widely available, they are essentially decentralizing AI development. This could lead to a scenario where AGI emerges not as a single monolithic system, but as a distributed network of specialized AIs working together. However, we must also consider the risks. A reckless race towards AGI, fueled by the availability of powerful models like LlaMa 3.1, could lead to hasty and potentially dangerous developments. Personally, I believe the path to AGI will be long and full of surprises. Models like LlaMa 3.1 are important steps, but we are still far from true general intelligence. What is exciting, however, is how these advances are expanding our understanding of intelligence and the potential of technology. LlaMa 3.1 is a significant milestone in the journey of AI, but it's just one chapter in a much larger story, a story that we are all writing together. Remember, the future of AI is not something that simply happens to us. It is something we actively create. Each one of us has a role to play in this creation. Stay curious, keep questioning, and above all, continue imagining the possibilities. Subscribe to our channel, leave a like, and comment below on what new topics you would like to see in this format. Thank you, and see you next time.